Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In this lecture, I will discuss about introduction of mechatronic systems, what is sensors, what is transducers, and hydraulic and pneumatic actuation system. So first of all, I will discuss what is mechatronic system, their evolution, advantages, disadvantages, applications, and its classification. So first of all, I will discuss what is mechatronics. So basically, mechatronics is an interdisciplinary field that combines mechanical engineering, electronics engineering, computer science engineering, and control systems. It is used to design and develop intelligent systems and products such as CNC machines, robots, automatic washing machines, drones, etc. Then what is evolution of mechatronics? So in 1960s, coined by Japanese engineer Tetsuro Mori, engineer of Yaskawa Electric. Then in 1970 to 1980s, adoption of microprocessor and basic automation. Then further 1990s to present, integration of Internet of Things, artificial intelligence, embedded systems, smart machines, and Industry 4.0. So basically, the evolution of mechatronics is divided into three stages: 1960s, 1970 to 1980s, and 1990s to present. Then what is scope of mechatronics? So the scope of mechatronics are robotics and automation, smart manufacturing means Industry 4.0, medical equipment, MRI, prosthetics, etc., automotive systems, in automotive system, ABS, any anti-brake system, cruise control, etc. Consumer electronics में cameras, washing machines. Then what are the advantages of mechatronics? The advantages of mechatronics are high precision and repeatability, greater automation, better monitoring and control, energy and cost efficiency, real-time data acquisition. So these are the advantages of mechatronics. Then what are the disadvantages of mechatronics? So the disadvantages are complex design and integration, requires multidisciplinary expertise, higher initial cost, and troubleshooting may be difficult. So these are the disadvantages of any mechatronic system. What are the industrial applications of mechatronics? So these are the sector-wise application. The first sector is automotive. In automotive, its applications are airbags, ABS, engine control units, etc. In manufacturing sector, applications are CNC machines, SCARA robots, pick and place arms. In aerospace sector, its applications are flight control systems, autopilots, etc. In medical sector, its applications are automated diagnostics, robotic surgery, etc. And in agriculture sector, its applications are autonomous tractors, drone sprayers, etc. So these are the sector-wise industrial application of mechatronic system. Then now I will discuss what is autotronics, bionics, and avionics. It is the subsector of mechatronics. So basically, autotronics refers to the integration of electronics in automobiles to enhance vehicle performance, safety, comfort, and efficiency. It combines automotive engineering with electronics and control system. Application of autotronics are engine management system. It controls fuel injection, ignition timing and emissions. Anti-lock braking system ABS prevents wheel lockup during sudden braking. Airbag deployment system deploy airbags during a collision for passenger safety. Then automatic control, climate control maintains desired cabin temperature. Adaptive cruise control adjust vehicle speed based on traffic. Parking assistance and reverse cameras, vehicle telematics, real-time tracking, remote diagnostics, etc. So these are the applications area of autotronics. And what is autotronics? Integration of electronics in automobile is called autotronics. The second subsector of mechatronics is bionics. What is bionics? Bionics is the application of biological methods and systems found in nature to the design of engineering systems and modern technology. It's a blend of biology and electronics. What are the applications of bionics? Prosthetic limbs. It includes artificial arms and legs that mimic natural movement. Cochlear implants restore hearing by converting sound into electrical signal for the brain. Then artificial organs, heart, kidney and pancreas replacement. Bio-inspired robotics, robots mimicking the movement of an animal या insect. Wearable health device, monitor vital signs and physical activity. Smart skin, artificial skin with sensory capability. So these are the applications of bionics. And what is bionics? The electronics involved in biology is called bionics. Then third subsector of mechatronics is avionics. What is avionics? Avionics refers to the aviation electronic system used in aircraft, satellites and spacecraft for communication, navigation and flight control. Means electronics involved in aviation field is called avionics. What are the application of avionics? First one is flight control system. It manages aircraft stability and control. Then navigation system, GPS, inertial navigation and radar system. Communication system, it includes radio, satellite and data link communication. Then weather radar, detect and display weather conditions. Autopilot system, control the aircraft without direct pilot input. Cockpit displays, multifunction displays and head-up displays HUD. Flight management system, assist in route planning and performance monitoring. So these are the application of avionics. Now I will discuss what is sensors and transducers. So first of all, what is sensor? So basically, a sensor is a device that detects changes in the environment and converts them into signal, usually electrical signal. And what is transducer? A transducer is a device that converts one form of energy into another. All sensors are transducers, but not all transducers are sensors. Then what is types of sensors? Now I will explain types of sensor based on what they measure. So basically this is sensor type, what it measures and their examples. So basically first one is temperature sensors. It measures heat. The example of temperature sensors are thermistor and RTD. Then second one is pressure sensor. It measures force per unit area. And the examples of pressure sensors are piezoelectric sensors. Then third one is proximity sensor. It measures distance. And the examples of proximity sensors are inductive, capacitive sensors. Then light sensor. It measures light intensity. Photodiodes and LDR are the examples of light sensors. Then motion sensor. It measure speed and acceleration. Encoders, gyroscope are the example of motion sensor. Then level sensor. It measures fluid level. And the examples of level sensors are ultrasonic sensor. Then gas or smoke sensor. It measures chemical concentration. And the examples of gas or smoke sensors are MQ series sensors. Then touch sensor. It measures contact or force, and the examples of touch sensor are tactile sensor. So these are some sensor type, their measures and what they measures and their examples. Then types of transducer. So basically, what are the types of transducers, what it converts and its example. The first one is electrical transducer. It converts physical energy into electrical energy. The example of electrical transducers are thermocouple, and it converts heat to voltage. Then mechanical transducer. It converts electrical energy into mechanical energy, and the example is solenoid, electric to motion. Then third transducer is piezoelectric transducer. It converts pressure into voltage, and examples force sensors. Then optoelectronic. It converts light to electric, and its example is photovoltaic cells. So these are the different types of sensors and transducers and their examples. Then what are the characteristics of sensor and transducer? The first characteristic, sensitivity. What is sensitivity? Output change per unit input is called sensitivity. Then what is accuracy? Closeness to actual value is called accuracy. Then what is precision? Repeatability of measurement is called precision. Then range, minimum to maximum measurable values is called range. Then linearity, proportional output across the range is called linearity. Then response time, time to respond to a change in input is called response time. Then hysteresis, output difference for increasing versus decreasing input is called hysteresis. Then drift, change in output with time without input change is called drift. So sensor or transducer should have these characteristics like sensitivity, accuracy, precision, range, linearity, response time, hysteresis and drift. Then now I will discuss hydraulic and pneumatic actuation system. So first of all, I will discuss what is hydraulic and what is pneumatic. So basically, hydraulic and pneumatic actuation system uses pressurized fluid for generation, transmission and control of power. In hydraulics, with the help of pressurized liquid, means it may be mineral oil. So by the help of pressurized liquid, we can generate, control and transmit the power. And in pneumatics, by the help of compressed air, we can generate, control and transmit the motion. It's called pneumatic. So first of all, I will discuss what is hydraulic and pneumatic, their features. So the working fluid of hydraulic is incompressible fluid, whereas in pneumatic it uses compressed air. Pressure range in hydraulics high up to 700 bar or more, in pneumatics low 6 to 10 bar. Force generation in hydraulics high, pneumatics moderate. Speed, hydraulics slower, pneumatic faster. And applications, hydraulics used in heavy duty machineries, whereas pneumatic used in robotics, automation and tools. Then now I will discuss different components of hydraulic and pneumatic system. The first component is pressure control valve. These valves regulate the system pressure to protect components and ensure correct operation. These are different types. First one is pressure relief valve. open to release excess pressure and prevent damage. Then opens when system pressure greater than preset pressure. Second one is pressure reducing valve, maintains lower pressure in a part of the system. Then sequence valve, ensure operation happens in a specific order by maintaining pressure threshold. And last one is unloading valve, diverts flow when pressure reaches a set value. So this is the symbolic representation of pressure relief valve and pressure reducing valve. Then second component is direction control valve. They control the path of fluid flow, determining the direction in which actuator move. It can be classified into 2x2-way valve, 3x2-way valve, 4x2-way valve, or 4x3-way valve. The first digit represent ports and second digit represent position. So 2x2-way means 2 port 2 position, 3x2 means 3 port 2 position, and 4x2 or 4x3 means 4 port 2 or 3 position. 5x2 means 5 port 2 position. These are the symbolic representation of 2x2-way DCB, 4x3-way DCB, 3x2-way DCB, and 5x2-way DCB. Methods of actuation. Their position can be actuated by different methods. One is manual operated, solenoid operated, mechanically operated, and pneumatically operated. Then third one is check valve or non-return valve. This is the symbolic representation of check valve or non-return valve. A check valve, also called a non-return valve, is a one-way valve that allows fluid, liquid or gas to flow in one direction and prevents backflow. Different types of check valves are swing check valve, lift check valve, ball check valve. And its application used in pumps, pipelines, water system, and compressed air system to prevent damage from backflow. Then fourth component is rotary actuator. These actuators convert fluid pressure into rotational motion. Types: hydraulic motor, deliver high torque, slow speed. Pneumatic rotary actuator, short rotational angle, example 90 degree to 180 degree. Its application: it is used in robot arms, valve actuation, and industrial clamping device. So this is the symbolic representation of pneumatic rotary actuator, and this is the symbolic representation of hydraulic motors. Then fifth one is accumulators. So a hydraulic accumulator stores potential energy in the form of pressurized fluid and released it when needed. There are different types of hydraulic accumulator. First one is bladder type, piston type, and diaphragm type. So this is the diagram of bladder type, this is piston type, and this is the diaphragm type, and this is symbolic representation of hydraulic accumulator. So the main function of a hydraulic accumulator are: it compensates for pressure fluctuation, provide fluid during peak demand, emergency backup power, and shock absorption. Now I will discuss what is pneumatic sequencing. Basically, pneumatic sequencing involves controlling multiple actuators in a specific order using logical arrangement of valves and actuators. Common tools: limit switches, pneumatic timers, logic valves, sequence valves, etc. And the examples of pneumatic sequences are A plus B plus, A minus B minus, yeah, A plus B plus, B minus A minus. These are the some numerical sequencing problem, and this is the representation of A plus B plus, A minus B minus sequencing problem. So this is all about for this lecture.